Alright, FRQ2. After deciding to get back in shape, Mr. Bear began a fitness program designed to improve his performance on 5K. On the initial day, he ran his base timeline. At time equal to t is equal to 0, he ran 5K in 54 minutes. So right here, give me the one of the point. What? 0, 54. For the next several months, he evaluated at the end of each month, and he performed, recorded. After 15 weeks, t is equal to 15, he ran in 42 minutes. So 15, 42. His runtime can be modeled by the function a plus b natural log of t plus 3, where the r represent the time in seconds and t represent the number of weeks since the initial program. All right, initial. I look at it and I'm thinking, ooh, that does not look like the regular regression we've been doing. That's the special one. So it tells me I need to customize it. So I'm like going to keep that in mind. Letter A, use the given data to write two equations that can be used to evaluate. Okay, so you're going to take the 0, plug it into t, set the whole thing equal to 54. So 54 is equal to a plus b natural log of, put the 0 in here, 0 plus 3. That's first equation. Second equation comes from the second point. 15 goes into t, set that equal to 42. 42 is equal to a plus b natural log of, what, 15 plus 3. That's all you need. Remember, this is the easiest point. You don't even have to do any math there. Just plug it in. Common mistake for the first one, honesty, comes from where you, instead of writing as a 54, you're writing as like r of 54. Like, no, please don't do that. Number 2, find the value of a and b and use as a decimal. So this one, you can do, you can solve this algebraically, which if you're a heron, I taught you both ways, right? So you do it algebraically or use decimal and then do the custom regression. I'm going to show you both because everyone has different preference. Okay, so I'm going to solve algebraically first. Ooh, do I want to? Sure. Okay, so 54 is equal to a plus b natural log of 0 plus 3 is 3. Second equation, 42 is equal to a plus b natural log of 15 plus 3 is 18. Okay, all right, so I got the equation side by side. I'm going to subtract one from the other like this. Change the color. There we go. I'm going to go ahead and subtract from the top to the bottom. 54 minus 42 is 12. Equal to a minus a, you eliminate it. That's what we want. And over here, b natural log of 3 minus b natural log of 18. B is a common factor. I can factor it out. There you go, is 12. So what is b equal to? It's going to be 12 divided by this whole thing, natural log of 3 minus natural log of 18. Sorry, you can't see it. So I'm going to go over here and on decimal, since I have a calculator with me, I'm going to do 12 divided by natural log of 3 minus natural log of 18. Folks, that's your b value, negative 6.697. Now you have to find the a value. So how are you going to find the a value? Do that like annotator. There you go. So knowing what the b is, you can just pick one of this equation. I'm going to choose the top one. So 54 is equal to a plus b natural log of 3. I know what the b is. I'm going to go ahead and subtract 54 minus b natural log of 3 is equal to a. You with me? And then I'm going to go over here and then do 54 minus, what's the b? This number right here. I have to type it. 6. There you go. Okay, be careful over here. Hold on, time out. So I'm going to let, oh, this is not like my calculator. Okay, 54 minus parentheses. That's your b value. Negative 6 point, be careful, those are double negatives. 6, 9, 7, 3, 2, 7, 5. That's good enough, right? Okay, times what? Natural log of 3. That's your a value. Whew. So we're going to write down a and b. Honestly, obviously, if you have your calculator, you're least likely to do that. So let's use decimal. So let's just erase the part that I don't need. I'm gonna keep that the tab A and the first two lines over here, just so that I can't. All right, now let's use a Desmo, shall we? So I'm going to go to plus, table, and then put the data as in 0, 54. And this is what I recommend you using it, not algebraically. All right, run the regression. Boop. I am doing what? At the logarithmic, and it's going to say, beep, 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 you're wrong. So what do you do? Instead of that 0, that I just don't like that 0 value. Put the arbitrary value in. I'm going to put 2. 3 dots, custom. And then what do we want? We want the a plus b natural log of t plus 3, a plus b natural log of x, that's your input, plus, oops, x plus 3. You type it in your custom regression right here. And now you go back to it, and instead of 2, put that necessary 0 that we had before. And now that's your a value, that's your b value. Do you see how they're the same thing that we got? A and b. And then you're going to write it, a value is 61.35777, b value is negative 6.69733. Please know how to do the custom regression. Okay, so I don't need this one. I'm going to just erase it. Letter B. Clear. Okay. All right, use the given data to find the average rate of change between 0 to 5. Okay, so what is the name of the function? I guess we haven't even named it yet. Was it R of t? I don't know. Okay, so the formula goes f of b minus f of a over b minus a. That's a generic one. You should be able to say in sleep, a is 0, b is 15. Instead of function f, you know what? I'm just going to use function f. No, r, fine. Is it r? R of t. Okay, r of t. I'll use r. So it's going to be r of b 15 minus r of a 0, 15 minus 0. The problem here is that my Desmo has no idea what the function r is, so I have to tell itself. So let's go. R of, do you want to use x or t? Fine, let's use t equal to what? A. This a. You can use a plus. I can use b. Natural log of t plus 3. So now I told Desmo what my function r is. And underneath it, I can just go r of 15 minus r of 0. Be careful with all the capitals and lowercase. And are you using input as a x or t? It all has to be consistent. So be consistent with that. So I got that written down. According to my Desmo, I got negative 0.5. 0.8, excuse me, I can't even talk. There we go. On the work, you have to show this part right here, the subtraction part and division part. I know you use Desmo, but you still have to show this work right here. Why? Read the direction. Show the computation that lead to your answer. Number 2, interpret the meaning of your answer in the context of the problem. So the context of the problem is Mr. Bear is measuring what? His 5K running time? 5K running time from 0 to 15 weeks. And it's decreasing 0.8 minute per week. Remember, this is the slope, folks. Slope. So, I'm going to just go over here. And then I'm going to zoom fit and kind of look at the graph with you. So there you go. There is his graph. So initially his speed was 54 minutes. It took him 54 minutes. And then he came down to 42 minutes over the next 15 minutes. So the slope connecting these two lines was negative 0.8. Number 2 is saying interpret the meaning of this slope, 0.8, negative 0.8. I'm going to say that means for first 15 weeks, Mr. Bear decreased his running time 0.8 minutes every week. Sorry. All right, what do I have to include? Make sure you have to say the first 15 weeks or week 0 to week 15. You have to tell me. That's the range we're looking at. And then since it's a negative, its time is decreasing 0.8 minutes, and then it's every week, right? So week 1, the average is going to be 0.8 each week. Make sure you say each week. Consider the average rate of change from 15 to p, where p is greater than 15. Okay, so I don't need this anymore, so I'm going to clear it. I need a little bit of space on my graph. Are these average rate of change less or greater than the average rate of trend from 0 to 15? Explain your reasoning. Your explanation should be referenced to the graph of R. All right, the hard question. So let's visually talk about it first. What is the average rate of change between 0 and 15? We just did that, wasn't it? This green line. This green line from 0 to 15 had a slope of the average rate of change of negative 0.8. Now they want you to compare that graph, that slope, with what? 15 to something else. 15 to something else later, which is going to be more of well, can't draw a straight line. So they want you to compare the slope of a green line versus the slope of a brown line. Which one is bigger? Be careful, both are negative. Which one is bigger? The brown line will be bigger because it's less negative. Right? So the average rate of change from 15 to p, the brown one, is that one less or greater than the average rate of change from 0 to 15, the green one? Well, the brown one is going to be greater. Explain your reasoning. Because I don't want to write it, so you listen. Because our graph is concave up. Concave up. So the average rate of change slope from 0 to 15 will be more negative than average rate of change from 15 to p, where p is greater than 15. And to make your answer stronger, I highly recommend you graph it. Okay? Because that's easy. Like sketch it on your answer. So there is a 0, there is 15, there is a p, and literally show that's, well, you can I guess you're not gonna have different color. 0 to 15 versus 15 to p. 15 to p will be greater than 0 to 15 because the slope is going to be greater.